Hello folks, this is the video tutorial for homework number 4, lab section 53. There are two problems here, and the difference between the homework for this lab section, which is 53, and the lab section 54 is here you have to submit problem 1. For lab 54, they're supposed to submit problem number 2. Okay, now, uh, that being the case, I will for you guys, 52, I will only do problem 1. And if you want to see how this problem is done, then go to the video for lab section 54. Okay? All right. Very good. So the problem is this. You have a part like that. Has to be done as an assembly. You have a part like that, and you have these pins which are inserted symmetrically into these holes, and then the ends of these pins are all clamped, and then on these faces you have a pressure applied. That being the case, you stare at it and then you come up with the conclusion that all you need to do is to model 1/4 of that. You model 1/4 of this and also make a cut through the depth of this. So basically, you're taking 1/8 of that model. Now, you have to make a decision whether you want to make 1/8 of this model. It's up to you. And then go and uh, uh, create the problem, model the problem, or you want to model the whole thing and then start cutting it with the three planes that I was talking about. This way, vertically, and through the depth. That's entirely up to you. So my approach, at least for this problem, is going to be I will make the whole model, except that I will not make these two pins because you know that when you cut it horizontally, and vertically, okay, and you discard these three pieces around it, all that is left here, these two pins are not going to even show up. So I'll make this entire geometry, this block with 4 holes, and I will make 2 pins, and I'm not going to make the other 2 pins because I'm going to start uh, cutting it with symmetry planes. Okay, that's how I'm going to do that. It really doesn't matter. It's up to you how you want to approach your problem, and that's entirely up to you. Okay, now remember that this has to be done in assembly, and the most appropriate element are solid elements. Now, I don't anticipate, but some of you may decide. I don't advise that. I don't advise that because in all likelihood you will not succeed to finish the problem, and you lose a lot of marks. Somebody might try to use beams and shells for this problem. Although it is possible, I don't advise it at all. Okay, so let's go ahead. If you start with a product file, immediately you're going to save it. File, save management, save as, desktop, new folder. This is homework 4, lab 53. This is 53. And obviously it's going to be problem 1, but that's okay. So I'm going to do that later. So product is right here in that folder. Your student ID number 1, 2, 3, 4, 5, 6, 7, 8, 9. Your last name, Euler. This is homework 4, lab 53. And this is problem 1. As I said, problem 2 is not going to be doing in this. It's not going to be done in this video, but it's going to be in the one which is with lab 54. So lab problem number 1. Okay, good. So that's our product. And the first thing I'm going to do, I'm going to insert the block in it, that block with 4 holes. So insert a new part in there. And I'm going to call this thing the block properties. I'm going to call this thing block and block. Okay. Let's make the block. I double clicked on this line, which is part. You see, this is a part. This is a part. Double click on this thing. You put in part design. Actually, you ended up in generative shape design because that was the last thing that I did. So I want to go to part design, or just go to part design. See that? Single gear. On a convenient plane, on that vertical plane, I will sketch that block with 4 holes. So let me start with a rectangle or a square centered here. Okay. And let's dimension this thing to match dimensions that I have in the drawing. Now this is 6 inches. This is 6 inches. So is this one 6 inches? And then I have to make 4 holes. 4 holes. Strictly speaking, you don't need 4 holes. You can make 2 of them because the other 2 are going to disappear anyways. But I'll make it exactly like it is. Okay, I'm just doing too much extra work. That's all. So let's put it there. Dimension these things. So this one, I think the diameter of these holes is the diameter is 2. Okay, diameter is 2. I'm sorry, diameter is 1. Diameter is 1. And this one also, diameter of this one is also 1. Okay, now I'm too lazy to do the other holes, although they're not needed, but I'm going to mirror these. But let's first position it in the right spot. So this distance to this distance, this is supposed to be, I think I made a mistake somewhere here. This has to be actually 12. Sorry, this is 12. I thought it was 6. Okay, that's all right. And this one is 12 also. Okay, now the distance from this point to this axis is 3. Okay, very good. And the distance from this center to that axis is also 3. 3. And if I insist on making these holes, although I don't need it, you can always mirror it. For example, here's the mirror. Mirror this with respect to that, right there. And mirror this with respect to that. It's there. At the end, when you make these cuts, then these 2 other holes become redundant. And now we're going to pad it. The thickness of this part, this block, is, it says 1 inch. So if you do a mirror extent, you're going to go 0.5 in each directions. Okay, there we are. Okay. Now this entire assembly is made out of steel. So at the end, I'm going to declare the properties. Okay, good. All right. So click on the floppy. Go all the way to top level assembly. Go all the way to top level assembly, and click on the floppy, and it's going to save the parts for you. Let's do the pins. I'm going to do 2 of the pins. So although the pins are identical, you can get away with making 1 and using copies of it or instances of it. I'll make it. It's too much of a hassle. You can get into trouble. So insert a new part in there. You know, this is going to be top pin. How about that? Right click properties, top pin. Top pin. And the part name is top pin. Top pin, just make it. Double click on the top pin. On a convenient plane, on that vertical plane, I will sketch. I'm doing a top pin, right? So I'm going to project that circle. That circle I'm going to project right there. Exit, and then pad it. Mirror extend. Now the length of each of those pins is 6 inches, so I'll do 3 inches in each direction. Mirror extend, that'll make it 6 inches. There we are. This is the first pin. Let's go all the way to the top. Insert a new part. No. Right pin. This is terrible the way I'm doing it because you can actually do a copy and paste and it's going to work. But so copy paste of this part, this last top pin part. So, but I'll do it the long way. So it's going to be right pin, and right pin. Okay. So okay. Make it. Double click on it. On that same plane, vertical plane, I will sketch, project that circle. There we are. Exit, pad it, mirror extent, 3 inches in each direction, and there we are. Yep. Okay, now we're going to make everything out of steel. I think the property is steel, if I'm not mistaken. It says the steel, yeah, steel assembly. Metal, steel, and if you put it on the top level assembly, all these parts are going to have the same properties. Now, before I go any further, notice that the reason I didn't make these two is because when I cut it to take 1/4 of it, this will not count, this will not count, etc. That's why I didn't bother making it. But if it's confusing, you go ahead and do that. Now here in the assembly, you have a split. You have a saw. Let me get the saw here. Where is the saw in the assembly? Let me get these things out. Uh, right there. You see this? Right there. Now, the bottom left corner, it says select a face or a plane to as or an existing split. So I'm going to select this middle. It says, look, when you cut this object with this middle plane, these parts are all going to get affected. Are you sure you want them? And the answer is yes. And which one do you want? I want all of them. And the plane is taken, and there we are. Notice that it cut it. And it asked me, told me that, look, some of these are going to get affected. Are you sure you want? Now, let's do another one. Another one. This one, this time we're going to cut it with this plane. And it tells you that some stuff are going to be, let's see now. It says parts possibly affected. So I want the block to be cut for sure. I want the top pin to be cut for sure. The bottom pin, I don't want it to be cut because that plane that I picked is not going to be affecting this. So we say, okay, notice that this is fine. Do another one, do another split, and select this horizontal plane. And it says, okay, these are possibly affected. I want the block to be cut, and I want the bottom pin, right pin to be cut. Okay, the top one is not going to be affected anyways. So we say, okay, and there we are. So the bottom line is that you need to have created something like this, made of 3 parts, this and 2 pins. If you want to do it like that to begin with, be my guest, no problem. The other thing is that notice that I didn't put any constraints between these parts. Okay, the reason I didn't do it is I don't anticipate to move these apart. But if you ever have to move these apart, you better put some kind of a constraints between that pin and this, block. Okay, so I did not put a constraint, but I'm saying that if there's any chance that you have to move these for whatever reason, you better put a constraint because otherwise they will not go back to the original position. They are made because of the way they are made in the correct position because of the way I made it. I'll leave it to you to worry about constraints. If you have any question, ask me in the lab, office hour, watch the videos, etc. So this is all done. So let's save everything. Okay, good. Now we're done here. We're going to go to the generative structure analysis. CATIA sees 3 parts. Immediately, it's going to mesh all of them. And the size of these meshes depends on the size of the part. Okay, if you want to make changes, you can do that. There are 3 elements, the 3 elements constructed here. One is for the block, the other one for the pin, and the pin. Let me make the block element a little bit smaller. I don't know, maybe 0.3. Okay, a little bit smaller. Okay, very good. Now, notice that the properties are automatic generated for 3D, automatic generated. And if you want to look at the mesh, put the cursor there, right-click mesh visualization. Okay. In the event you're asked to make a finer mesh around these holes, well, you can do that. And just watch the videos for the other 2 labs. You look at the one for lab 52. I'm making refinement around certain hole. Okay. Because this doesn't ask for it, but fine. Now deactivate the plot. Let's move on with the rest of the problem. First of all, surface slider. This is a plane of symmetry. This is a plane of symmetry. So is that, and so is the back face, and so is this little circle of the pin, and that little circle of the pin, and turn it around. This rectangle, and that rectangle, and that rectangle. All the stuff that I created by making that cut, including these little circles, semicircles, you have to put surface slider on it. Okay? Now, the next thing to do is to clamp these ends. These ends. You're told that these are clamped. So this is clamped, and this is clamped, and we say okay. And this end is subjected to a pressure. Where is that? Pressure right there. I'm going to apply pressure here. Now, what's the value of the pressure in this particular problem? It says 100 psi. Very good. Okay, in the right direction. You can see that. It looks like we are almost done. Not quite. You will see that this will bomb out. But let me save it first. File, save management. This analysis we haven't saved. Save as. What was the folder name? Homework for Lab 53. Let's go to the desktop. Homework for Lab 53 right there. And I'll give it the meaningful name. Your ID number 1, 2, 3, 4, 5, 6, 7, 8, 9 dash Euler dash. Now what did I call that part? I called it homework 4 Lab 53. This is homework 4 Lab 53. I think I called it also problem 1. Is that right? Move this thing here. Problem 1. Yep. Problem 1. And the analysis is analysis 1. So good. Say okay. Now, I'm going to run this thing to convince you that this will not run. And we'll discuss the issue of why is it not going to run. Don't worry about that warning message. Oh, oh, okay. It ran, but it is wrong. You'll see why. If I look at the displacement, let's change it to average ISO. It did run, but it's wrong. And make this thing material shading. You'll notice that this piece, the block, is getting compressed. That's not surprising. However, this pin, because it does not see that block, and the same thing here, they don't move at all. In fact, the block goes through the pin. You can see that, goes through the pin. If I animate it, you can see this. You see? The block is going through the pin. If I put it in a different view, you can see it better. Right there, you see that? Right there, right there. That's because with assemblies, you have to create the interaction between them. So let me stop this thing. Okay, by the way, one of the reasons this is so slow, it looks like I have a problem rotating it, things like that. It could be because these are parabolic elements. Let me go change it to linear so it runs faster. Linear, less accurate, but it will run faster. Okay, good. Let me run it again. Again, it will run, except that the block goes through the pin, just like before. Okay, here is your drawing, translation. Good. If you animate it, you see that it runs a lot faster. Yeah, that's because the element is less sophisticated, and I can do rotations and things like that a lot easier than when I have a parabolic one. Okay, good. So deactivate this. Now, we need to say that there is an interaction between the surface of this pin and the hole, and the surface of this pin and the hole. And that interaction is in the form of contact. Okay, so let me change the rendering here first of all. Rendering. So where's the analysis connection? Analysis support right there. Analysis support. The first one is general analysis connection. For the first component, I'm going to select the surface of that pin, and then I'm going to hide it. And for the second component, I'll turn this thing around and take the surface of the hole. It creates this thingy here, which represents the connection that you created. Don't worry about the way this thing looks like, but it did create the connection here, right there. You can see that when I select this thing, that thing lights up. Okay. Now, do another one for the bottom. So another connection. It's a good idea to give these connections meaningful name. For example, top pin, right pin, etc. I didn't do that. For the second component, hide this guy and select the bottom here. Okay. So we created two connections here, and we're going to declare both of them to be contact. Look at the face-to-face connection. Just because you create connection doesn't mean the problem is done. You have to say what kind of a connection. Is it fasten? Is it contact, etc. So it's a contact for this problem. So I'm going to select this to be contact. Don't worry about these things. Do not fool around with them at this point in your course. Don't fool around with them. But if you have any questions, please feel free to ask me. Another contact right there for the second one. See that? It puts these things, it looks like two things are contacting each other, or two things are contacting each other. It looks like that. Okay, so save it, and now run it. You see that the pins will actually interact with that block. It'll stop the block. So yeah, which was missing in the previous case. Good. So let's look at the deformation. You see this? Let's change the rendering and animate it. Let me get closer. You see? The block will not cut like butter through that pin. It just pushes the pin. The same thing down here. See, it's just pushing the pin. Okay? And you can look at the von Mises stress if you want. Okay, so you can see that this is very little stress here. And when you think about it, this was 1-inch thick piece of steel. Okay, 100 psi on that cross section is not really much of a force. So very little stress is going to be developed in the problem. Okay, excellent. So that is this. So I'm going to stop this thing, and for the second problem, watch the video for lab section 54, because they're the ones, they're going to submit this. Okay, you're going to be submitting the first one, your lab 53, right there. You submit problem 1. Okay, so let me see for a second. Stop the taping.